Chapter 1, Section 2 is on segments and constructing line segments. What we will learn: using the ruler postulate, copying segments and comparing segments for congruence, and how to use the segment addition postulate. The ruler postulate states the points in a line can be matched one-to-one with the real numbers. The real number that corresponds to a point is called the coordinate of the point. The distance between points A and B, written as AB, is the absolute value of the difference of the coordinates A and B. Notice there's no symbol above AB to represent its length or distance. Line segments that have the same length are called congruent segments. You can say the length of segment AB is equal to the length of segment CD, or you can say AB is congruent to segment CD. The congruent symbol is used for listing the segments congruent. If you want to say the lengths are equal, you do not include the symbol above the AB and the CD. The segment addition postulate states if B is between A and C, then the length from AB plus the length from B to C equals the length from A to C. Likewise, if AB plus BC equals AC, then B is between A and C. Measuring the length of a segment to the nearest tenth of a centimeter, we can see that this segment is approximately 3.4 centimeters. Measuring these lengths to the nearest 1/8 of an inch, we can take our ruler and line it up and see what the length is of the segments. For example, in the first one, we're measuring to the nearest 1/8 of an inch. So if we take a look, we have 1 inch, and then we have an additional 1/2 of an inch plus another 1/8 of an inch. Now 1/2 is the same as 4/8. So we have 5/8 of an inch, so it'll be 1 5/8 inches. Our second one, if we line it up, we can see from this one, for example, in number 2, that we have 1 inch and another 1/4 inch, which is 2/8 plus another 1/8, so 3/8. So this would be 1 3/8 inches. And that's how we'll measure in inches. You can try and look at the other 2 examples if you'd like. Moving on, plot the points on the coordinate plane, then determine whether the segments are congruent. So if we plot our points on our coordinate graph, our points are at -4, 3, plot the points on the graph, and then determine if we have congruent segments are the same length. P and Q. Here's our segment for PQ. and then negative 1, 4, and for R, S is at negative 1, negative 2. We can see that we can count out how many units that these are. 8 units for RS, 7 units for PQ, so they are not congruent. Our next example is finding the length of the segment XZ. To get the length from X to Z, we simply will use the segment addition, adding the two segments together. 14 plus 27 XZ equals, notice that again no symbol above for the length of it, which would equal a total of 41. For the other one, we're finding the length from C to D. So this time we have to figure out 19 plus what number is going to equal 25. If we subtract the length from C to D, 25 minus 19, we would get 6. Our next example, the cities shown on the map lie approximately in a straight line. Find the distance from Sacramento, California to San Bernardino, California. So we're finding the distance from Sacramento, which is here, down to San Bernardino. 158 miles to Fresno. Segment addition, we add the 230 miles it is from Fresno to San Bernardino, and so our distance from our 2 points equals a total, if we add them together, of 388 miles. Finally, the cities shown on the map lie approximately in a straight line. Find the distance from Albuquerque, New Mexico to Provo, Utah. For this one, we're going to have to subtract the two values so that we can find the distance between the 2 points. We're finding 680 minus 231. When we subtract these, we get 449 miles total. Last thing we have is a writing prompt. A postulate is a rule accepted without proof. An example of a postulate is the segment addition postulate, which again we can say that if we have a point B is between A and C, then A to B plus B to C equals A to C. Next, try some of the problems for on your own, and I'll answer questions on that tomorrow.